So in this video, we're going to focus on adding vectors analytically. That means by component method and not graphically. So say I'm trying to add two vectors which are 50 newtons and another vector which is also 50 newtons. So both vectors are directed to the east. I have 50 newtons east plus another vector which is 50 newtons east. Bear in mind that vectors are represented via an arrow. It should have a head and a tail. So it turns out that the result of the two vectors, when we add it analytically, is just 100 newtons directed to the east. So it's positive 100 newtons. Whenever you have vectors which are parallel to each other, that means they both have the same direction, 50 newtons and 50 newtons, both directed to the east. We just simply add the magnitude and then copy the direction. In this case, the direction of the two vectors is east, so we just add the magnitude and then copy the direction. It's really convenient. So that's it. The second example is when we have vectors which are anti-parallel. That means they both face the opposite direction. So say we have a vector here which is 100 newtons directed to the east, and then I have another vector which is let's make it larger than 100, so let's make it 150 newtons west. Whenever you have two vectors which are anti-parallel to each other, just subtract. So this is 150, take the bigger number, 150 minus 100, we have 50 newtons. And then the next question that we have to resolve is, which direction should we follow? We follow the direction of the bigger vector, which happens to be 150 newtons. So we use west. Don't get confused, N here means newtons. That's the unit for force, SI unit for force. So this means 50 newtons directed to the west. It's like this. So I have 100 newtons to the east, and I have 150 newtons to the west. So we're trying to calculate the space here. And that happens to be 50 newtons. Next example is when we have vectors which are perpendicular to each other. So the next example will give an illustration of how this would look like. So say I have 30 newtons of force directed to the east, and then I have 40 newtons directed to the north. So let's make that 40. You will know the resultant force by finding the hypotenuse. So this is the hypotenuse of the right triangle that was formed. So this is our resultant force. That's the addition of our force 1. Let's call this force 1, and this is force 2. Force 1 plus force 2, if you take the displacement, the shortest distance between the origin and the final destination, that's actually our displacement, and this is our angle. So in order to find the resultant force, which is just the hypotenuse, we of course use the Pythagorean formula, which says that it's C is equal to square root of A squared plus B squared. So for us to find FR, in this case, we just take out the square root of the sum of the squares of the other two sides, or the two legs. So 40 squared plus 30 squared. Getting the square root of 40 squared plus 30 squared, we have 50. So FR should be 50 newtons, or the resultant force should be 50 newtons. If you're familiar with a 3, 4, 5 triangle, this should make it 50 newtons. So the next question is the direction. Since vector should have a direction, the resultant force should also have a direction, but we only have the magnitude. We get the magnitude of the angle by using this formula. Theta is equal to arctangent of the y component over the x component. So we have theta is equal to arctangent of y, which is 40 over 30. So we will have our angle as 53.1 degrees. So your final answer should be reported as, let me pick a color. Your final answer should be reported as 50 newtons with an angle of 53.1 degrees. And if you try to graph it on a Cartesian plane, it should look like this. And our resultant, which is represented by the green line, is at the first quadrant. So this should be north of east. The final answer should be that. Okay, let's have another example. So I have, let me try to write it. I have a vector directed west, which is 50 newtons, and I have another vector which is directed south, which is 120 newtons. If we try to rewrite that, it should look like this. If we try to rewrite that in a head-to-tail fashion, it should form a right triangle. 120 newtons. And our resultant should be this, the hypotenuse. And the angle should be here. So if you're familiar with 5, 12, 13 triangle, the hypotenuse should be 13. Let me just... Hypotenuse should be 13. But if you're not familiar with the 5, 12, 13 triangle, you can get the hypotenuse using this formula. C is equal to square root of 50 squared plus 120 squared. You should get the FR as 130 newtons. And then to find the angle, we should use arctangent y, which is 120, over x, which is 50. And let's see what it is. Arctangent of 120, 50. That's 67.4. Our angle is 67.4 degrees. Keep in mind that that angle is inside this triangle. So this is 67.4 degrees. But when we report the answer, we should report the angle in reference to the positive x-axis, which is this one. This is the positive x-axis. So instead of giving me 67.4 degrees, we should make an angle in reference to the positive x. So it should look like this. How do we find it? Keep in mind, or bear in mind, that one straight line is 180 degrees, this straight line. So if you try to add 67.4 plus 180, you should get the angle of this resultant vector in reference to the positive x-axis. So 180 plus 67.4 is equal to 200 theta in reference to the positive x-axis should be 247.4 degrees. Okay, so your final answer should be reported as 130 newtons, 247.4 degrees. But if you wanna use the reference angle, which is 67.4, it should lie on the third quadrant, so you should put south of west. So you can use this 130 newtons, 67.4 degrees, but you should indicate where your reference angle is, and it's at the third quadrant, so that makes it south of west. All right? Perfect. So let's try another one. So we have 50 newtons of force directed to the east. And we have another vector which is directed to the south. Let's make it 17 newtons. And our resultant vector should be the hypotenuse. Let's call this F sub r, or resultant force. And you should get the hypotenuse using C is equal to 50 squared plus 70 squared, which is the sum of the squares of the two legs. So our FR should be square root of 50 squared plus 70 squared, 86 degrees. I mean 86 newtons, not degrees, that's not the angle yet. So we have 86 newtons for our FR. Next thing that we should look for is our angle, or our direction, which is described in degrees, since this is an arc. So again, let's find our reference angle of theta sub r, which is arc tangent or inverse tangent of 70 over 50. And we should have 54.5. Our reference angle is 54.5 degrees. But again, if you try to graph this on the Cartesian plane or an xy plane, oops, it will lie on the fourth quadrant. So what we want to report the answer to is from the positive x-axis, right? So we should have this all the way from the positive x-axis to the second quadrant, third, and then finally to the fourth. So to find the reference, the angle from the positive x-axis, we just subtract this angle from 360. Keep in mind that one full rotation is 360 degrees. So if we try to subtract this angle, 54.5 from 360, we would find the reference angle from the positive x-axis. So angle theta should be 360 minus 54.5. We have 305.5 degrees. So that's our answer, 86 newtons with an angle of 305.5 degrees. For our next example, I'll introduce the component method. And before we go to that, I want to explain the concept of getting the components of a vector. So say we have a vector here. Let's call this f. This f actually has its x and y components. So this is this x component because it's horizontal. X is always horizontal though. And our y, let's pick another color, should be vertical. So let's call this f sub x, and we call this f sub y. You get the x component, or the f sub x, using f cosine theta. Usually it's f cosine theta. Cosine, if you try to recall, SOHCAHTOA is involved with anything that is adjacent. So our x component here is adjacent to the angle. Adjacent means next to it or below it. So we should use cosine for x. And since f of y is opposite of the angle, we use f sine theta. But sometimes x will use sine and y will use cosine depending on the reference angle. But just bear in mind that if it's opposite of the angle, you should use sine, and if it's adjacent, if you want to get the side or the component which is adjacent to the angle, you should use cosine. But usually it's this two. And if you want to get the hypotenuse, again, it should just be f of r is equal to square root of f of x squared plus f of y squared. And then if we want to get the angle, it's theta is equal to arctangent of y over x. So these are the four important equations that you need to know, which is going to help you at this point of the video. So let's go to actually adding vectors. So whenever you want to add vectors which involves one or more vectors which has an angle, you should use the component method. And I'm talking about this. So say we have a vector which is 100 newtons directed to the east, and then I have another vector which has an angle. Its magnitude is 150 newtons, and it has an angle, just like what I told you, of against the horizontal. So theta is equal to 30 degrees. So how do you add this one? You can't use just addition because it's not parallel. You can't use subtraction because it's not anti-parallel. And you definitely can't use the Pythagorean formula right away because it's not forming a right triangle or a right angle against each other. They're not perpendicular against each other. So at this point, we're going to use the component method. So let's get the x and y components respectively of the two vectors. So first, let's list down what we have. So we have 100 newtons to the east, and then we have 150 newtons, 30 degrees. All right, so we will get the x and y components of these two vectors respectively. So let's start with the first vector. Its angle, since it's directed to the east, if we try to graph this on an xy plane, it's going to look like this. So it doesn't have any angle because it lies exactly on the x-axis. So the angle here should be east or 0 degrees. If we want to get the x component of this one, it's actually 100 because cosine 0 is 1 and 100 times 1 is just 100. If we want to get the y component of this vector, we will have 0 because sine 0 is 0 and 100 times 0 is just 0. Let's go to the second vector. Since we have an angle here, we should use 150 because that's the magnitude. Remember, it's f cosine theta. So we have 150 for f, cosine 30 because that's the angle. So we have 150 cosine of 30. We have 129.90. And then for our y, we have 150 sine of 30. We have 75. By the way, 150 sine of 30 degrees should be 75, not 70. So please, in your papers, erase 70 while you're calculating on your own and replace it with 75. You should arrive with a correct answer. In this video, and in this specific problem only, the final answer is inaccurate since the y component of 150 should be 75 and not 70. But please just look at the process, not the final answer. At this point, I'm adding all the f of x's and f of y's. Now, back to the video. This. I want you to forget all the other stuff that we have and just focus on our summation of all the f of x and f of y components of each vector. So let's try to regraph this on an xy plane. So we have, let's do head to tail method. So we have 229.90 for the x. So we have this 229.90 newtons. And then for the y, we have 70 newtons. Notice that at this point, we form two vectors which are perpendicular to each other. So we will know the resultant by getting the hypotenuse, which is f of r. At this point, we can now use our Pythagorean formula, which is f of r is equal to square root of 229.9 squared plus 70 squared. So let's see what our f of r is. Square root of 229.9 squared plus 70 squared. We have 240.32 newtons. That's the resultant force. And if you want to find the angle here, let's use theta is equal to arc tangent of our y, which is 70, over 229.90, which is our x. So let's try. Shift tangent of 70 divided by 229.90. We have 16. Theta is equal to 16.9 degrees. So your final answer should be reported as 240.32 newtons with an angle of 16.9 degrees relative to the positive x-axis. So that's it. Very easy, right? Let's try one final example before I say goodbye to all of y'all. So let's try to draw a Cartesian plane here. Okay, this is our y and this is our x-axis. We have, let's try to use different colors for each vectors. I have a vector here which is directed to the west. Let's say it's 300 newtons. And then I have another vector which is directed to the south, which is 400 newtons. And then I have another vector which is, let's put it here. Okay, this is 500 newtons, and this has 50 degrees of an angle. So again, very basic step. If you're a beginner, you might want to list down everything that you have first. So you have 300 newtons of force directed to the west. You have 400 newtons of force directed to the south, and then 500 newtons with 50 degrees relative to the positive x-axis. So let's get the x and y components of these vectors. So the x component of this one should be guess what? Since it only has an x component, everything on the x-axis, if it's a vector directed to the east or just west, its magnitude is automatically the x component of it. It wouldn't have any y component. It's always just 0. Same with this one. This one is only directed to the south. Any vector which is directed to the south or north will automatically have its magnitude as its y component. So it has 400 newtons. But be careful. Since this one is directed on the second quadrant, it will have negative 300. Remember that this part, this x-axis here, is negative. So if it falls on the negative x-axis or the negative y-axis, our x component should also be negative. So since this one falls on the negative y-axis, its y should be negative as well. All right, I hope you got that. So this is automatically 0 since it doesn't have any x component. So let's go to 500. So in order to find the x component of 500, we have 500, which is its magnitude, cosine of 50. We have 321.39. Let's put a line here. And then for our y component, we have 500 sine of 50. We have 383.02. I'm running out of space. So the next step is finding the summation of the x and y components. So let's use another color. I'm going to use dark green. Okay, so we have summation of all the f of x's. We have negative 300 plus 321.39. The answer is pretty obvious, but I encourage you to use your calculator if you're a beginner. So we have 21.39 newtons. And then for the summation of all the f of y's, we have negative 400 plus 383.02. We have negative 16.98. Okay? All right. So let's try to work with what we already have here. I want you to forget about this one and let's try to rewrite the f of x and f of y, the new f of x and the new f of y that we have. So let's try to write this. Actually, let me delete this because we won't be needing these anymore. Okay, perfect. Let's move on. So we have our x component, our new x component, in the positive x-axis. So we should write this to the east. So we have 21.39 newtons. And then we have our y in the negative. So everything that's on the negative should either be on the west or south. But since this is y, it should be south. Okay. Perfect. So 16.98 newtons. And our resultant should be this one. The hypotenuse. F of r. So in order to find f of r, let's use the Pythagorean formula, which is 21.39 squared plus 16.98 squared. So let's try to see what the answer will be. See, that rhymed. 21.39 squared plus 16.98 squared. We have f of r is 27.31 newtons. So this is our resultant. And for our angle, we use arc tangent of the y, which is 16.98, divided by 21.39. So we have our angle as, let me just grab my calculator real quick, 16.98 divided by 21.39. We have, I'm not really sure if this is right because I just woke up. But anyway, you try it on your own calculator and see if it's right. It's 38.4 degrees. But again, this is that angle. And when we're trying to report the answer, we want to report it in reference to the positive x-axis. So we should do this rotation right here. Okay? So we have 360, because this, again, this whole rotation is 360. So if you want to get the angle of this resultant here in blue, sky blue, then you should subtract it, reference angle from 360. So 360 minus 38.4, we have 321.6. So our final answer should be reported as, let me pick another color, this one, 27.31 newtons with an angle of 321.6 degrees. You shouldn't put any direction anymore if you used the angle in reference to the positive x-axis, because this is understood that this is always going to be north of east. So you don't really have to put a direction anymore, since we know, or you give the reader the idea that it's in reference to the positive x-axis. So this is north of east by default. But if you want to use 38.4, it's okay. You can write it as 27.31 newtons, 38.4 degrees, and this one is on the fourth quadrant. So of course this is south of east. This one, south of east, because it's from the east and then it went to the south, this 38.4. So I think that's it in my study guide and my PowerPoint presentation, which I converted to PDF. I have some problems there. You can try it on your own and practice, because practice makes perfect. And don't you dare procrastinate, because if you procrastinate and don't do things that you can actually do right now, devote 1 hour for studying, I tell you, you're going to fail. In physics, or actually in any subject, science subject, which you consider hard, procrastination is always going to be your #1 enemy. And that's enough for now. I'm really hungry. I had to take my breakfast. See you on the next video. Bye.